Alright, so welcome to this follow-up video on bond enthalpies. Now we're just going to go over an example question to help us practice what we learned in the last video. Okay, so here is an equation. We've got C3H8 plus 5O2 gives us 3CO2 and 4H2O. And we need to figure out the theoretical delta H value. Alright, what is the theoretical delta H value for this equation? The first step we're going to do, let's break this up into steps. So step one is we need to draw structural formulas for everything. What this is going to allow us to do is figure out what bonds are actually being broken. Okay, now step two is we then need to figure out the sum of all bond enthalpies. Three is to determine the difference. What does this mean? It means what is the bond breaking energy minus the bond forming energy. Okay, so let's do step number one first. I'm going to draw our structural formulas. Okay, and our other reactant is oxygen. Now we have 5 of them. We need to make sure we write that 5 there so we don't forget. It's 5 oxygens. Now oxygen is double bonded to itself. Now this is going to become 3 carbon dioxides. So 3 carbon dioxides. Now again, carbon is the central atom, double bonded to an oxygen, double bonded to an oxygen. And we have 4 of the water molecules. H, single bond O, single bond H. All right, so these are all of our reactants. Okay. We need energy to break the bonds in these, and these are our products. Energy is going to be released when we form these. Energy in, energy out. Okay, so let's look at all the bonds that we are breaking. We are breaking CH bond there, and we're breaking 8 of them. So 8 CH bonds. Now a CH bond, if we look at our data book, is 414 kilojoules. So that's 414. We are also breaking these carbon-carbon bonds. Do not forget them. They are easily forgotten. And carbon-carbon is 346. All right. Now the oxygen, there are 5 of them. So 5 times the oxygen, the O double bond O, and that is 498 kilojoules. Okay, now let's quickly sum all of this up. 98, 6494. 6494 kilojoules. All right, now moving on to the bond forming process in the products. Okay, we are forming these C double bond O's. There are 2 of them, but we have 3 CO2s. So actually it's 3 times 2 times by these C double bond O's. And the C double bond O's, their energy is 804. 804 kilojoules. We also have 4 water molecules. Okay, 4 times the HO or OH bond. Now there are 2 of them in each water molecule. So it's actually 2 times by the HOs, and we got 4 H2O molecules. So in total there's 8. Okay. And the OH bond has 463 kilojoules in it. 463 kilojoules. Okay, so let's do the math and work out how much energy comes out of the system when we form the bonds. So we've got 6 times 804. So 6 times 804 plus 8 times 463. That should equal 8,528 kilojoules. So this is energy out, and this is energy in. Okay. Now what's our delta H? Delta H is equal to our energy in, 6494, minus the energy out, 8528. 8528, and that should equal to 2034 kilojoules. So that means for every mole of C3H8 that is combusted, we will release a total of 2,304 kilojoules of energy per mole. Yep, so per mole. That's our delta H. Now let's bring this, and so yeah, this is an exothermic reaction because delta H is negative. So let's just make a note of that. Now, if we bring it back to our energy profile diagram, we have an exothermic reaction, and so the profile is going to look something like this. Okay. Sitting over here on this line or this level, we've got our reactants. I'm just going to represent them as R, and our products represented as P. Okay. Now, the difference in the energy of the reactants and products is your delta H by definition, and that is equal to 2,034 kilojoules, all right, for every mole, per mole. Now, the difference between the energy of the reactants and the peak of the graph, well, this is energy coming into the system, right? This is the energy required to break the bonds. And the energy required to break the bonds is, we calculated, 6,000. So from there to there, 6,494 kilojoules. All right. And now the energy that is released, so that is from there all the way down to there. This is the energy released, and that is 8,528 kilojoules. Remember, this is energy out. Out equals bond forming. And this is energy in. This is bond breaking. We need more energy. More energy is released from the system, comes out from the system to form new bonds, than there is energy coming into the system to break the existing bonds. All right. So hopefully this helped you with understanding bond enthalpies. Now this will, like I said, come up pretty much for sure on the exam in some way, shape, or form. So make sure you know it. Any questions, please don't hesitate to contact me.